Section 10.3 Chi-square test for associations between categorical variables. For these sessions, we'll be use the chi-square test to determine whether there is an association between two categorical variables. We do have two tests for associations. Which test you use depends on how the data were collected. And both methods use two-way table to display data. Two-way tables means the contingency table. We talk about it on the session 10.2. The first test we call test of homogeneity. In a test of homogeneity, subjects are randomly selected from the different populations separately. One variable's relative frequency are compared across multiple populations. Collect two or more independent samples, one from each population. Keep in mind that the test of homogeneity, we do have two or more samples from different populations. Each object sample has a categorical value that is recorded. We only have one variable for the test of homogeneity. Look at this example. Collect a random sample of men and a random sample of women. Ask each person sample if they agree that global warming is a serious problem. So you can see we do have two different populations. One population is about men, one population is about a woman. And then we're gonna collect independent sample from each populations. And then we only have one variable. If they agree that global warming is a serious problem, so this is gonna be our variable. Another one called test of independence. In a typical test of independence, sample subjects are randomly selected from one populations. Okay, only one populations for the test of independence. And values of two different variables are observed. We have one populations, but we do have two different variables. Two variables' relative frequency are compared to one another within one populations. So we only collect one sample. For objects in the sample, we record two categorical response variables. So keep in mind for the test of independence, we only have one sample from populations and we do have more than one variables. Usually, we will have two categorical variables. Look at this example. Collect a large sample of people. So this is going to be one population. And record their marital status and income. Okay, so we do have two variables, marital status and income, two variables. Similarities in the two approach. In both situations, we are interested in knowing whether the two categorical variables are related or unrelated. So we'll be using the chi-square test statistic and the same chi-square distribution to find the p-value. Try this example. Just let me know if this is the test of homogeneity or test of independence. Okay, let's try the work. A polling organization asks a random sample of people for their party affiliation, Democrat, Republican, or other, and whether they think the minimum wage should be raised. If the organization want to test whether party affiliation and opinion on minimum wage are associated, would this be a test of homogeneity or independence? So think about it. Do they have one population or two population? And how many variables? One variables or two variables? There are two variables. One is the party affiliation and one is the opinion on minimum wage. So this is gonna be the test of independence. And then they only have a one sample, okay? Only one sample. There will be a random sample of the people. So one population and then two variable. So that would be the test of independence. B. In 2013, the organization surveyed adults in 8 countries that had legalized same-sex marriage, asking the question, should homosexuality be accepted? If the organization want to investigate whether country of origin and opinion are associated, would this be a test of homogeneity or independence? So first, think about it. Do they have a one population or more than one populations? Second, think about it. How many variables? Do they have a one or more than one? You can see here, they do have 8 countries. Okay, they surveyed the adults in 8 countries. So you could consider they do have 8 populations. And then they only have a one variable. The variable will be should homosexuality be accepted. So one variable and more than one populations. So that will be the test of homogeneity. Okay, right? So in order to working of the test of homogeneity and independence, they do have the same method. First, state the hypothesis. We do have the null hypothesis. There is no association between the two variables. Okay, another way to say is going to be the variables are independent. They are not associated to each other. Alternate hypothesis. There is association between two variables. So the variables are not independent, okay? Are not independent. So prepare, state the condition. First, random sample, independent samples and observations. Okay, last one, large sample. Expected count must be 5 or more in each cell of the table. So when you guys calculate the expected frequency, make sure at least 5 on each cell. Okay, test statistic, same formula. And then, since this is the contingency table, we do have a specific way to find the degree of freedom. Degree of freedom will be the R minus 1, the row minus 1, times the column minus 1. And then find the p-value. Okay? And if your p-value less than or equal to the significance level, we reject it. And then we're going to draw the conclusion, okay? And this is the step how you guys use your calculator to find the test statistic, p-values, and also the degree of freedom. Okay, example 2. The Yale project on climate change investigates views on global warming among the Republican Party. Republicans surveyed identified themselves as liberal, moderate, conservative, or Tea Party Republicans and also answer the question, do you believe global warming is happening? The results are sorted in the following two-way table. Number 1, is this a test of homogeneity or independence? So think about it, how many populations do they have? How many variables do they have? So we only have a one population. Samples are drawn from the Republican Party, one samples. And then we have a more than one variables in here. Okay, so this is gonna be the test of independence. Now, we're gonna find the subtotal. Okay, I want you guys try to find the subtotal and the grand total. Okay, first one, the Liberal Republican is gonna be 106. Okay, check the word. So the grand total will be 2,329. And then now I show you guys the first one, how to find the expected frequency. E11, we are talking about this guy. So we draw the line here, draw the line here. So the expected frequency will be 1010 times 106 divided by the grand total, which is going to be 45.96. Okay, try to do it by yourself. Find out all the expected frequency. Check your work. Okay, right? Actually, this part you guys can use the calculator to find the expected frequency. But on the exam, I want you guys show me the work, okay? Okay, no hypothesis. Republican type and opinion are independent. Okay, independent. So alternate hypothesis is gonna be a not independent. State the condition. Samples are random and independent. Large sample, so each expected value should be at least 5 here. Okay, right? Okay, the test statistic. Before we find the test statistic, I want you guys to state the degree of freedom first. What is the degree of freedom? Okay, how many row, how many column do we have? So we do have, when you guys counting the row and column, you don't count the total, okay? Only this part. So we do have a 2 row and 4 column. Okay, 2 row and 4 column. So 2 minus 1 times 4 minus 1. You should get the 3 in here. Okay. I'm gonna show you guys how to use the calculator after, okay? We just write it down, the test statistic and also the p-value should be equal to 0. So now, number 4, we're gonna use the p-values compared to your significance level. So that will be reject. And then we're gonna draw the conclusion. There is sufficient evidence to support there is an association between type of Republican and opinion. Okay, now let's use the calculator. Okay, we're gonna go to the matrix. Matrix is gonna be here. Okay, so go on second matrix. And then we're gonna go to edit. And then we're gonna enter for the A. So enter the row by column. Okay, so from our example, we have a 2 row. You're gonna press 2 and then enter, and then press 4 and then enter. You're gonna see they have the table in here. So you're gonna plug in the observed frequency. Okay, 72, enter, 335, 483, 120, 34, 205, 788, 292. Okay, right? Input the observed frequency. Okay, when you're done, you're gonna press second, and then mode. Mode means like the quit, second mode for the quit. And then you're gonna go to the stat, go to the test, and then I'm gonna go up, will be faster. Go to the chi-square test. Okay, session 10.2, we use the chi-square goodness of fit test. And these sessions will be using the chi-square test. Enter. So I already input the observed frequency on the A. For the expected frequency, they're gonna calculate by the calculator. Okay, so you don't need to input anything for expected frequency. Go to calculate. Okay, so check your work. Your test statistic is gonna be 151.59. And then degree of freedoms, that will be equal to 3 here. And then you have the p-value. That's a 1.19 times 10 to the power of negative 32. Okay, so that will be really, really small. That's going to be equal to 0 here. Okay, how can you check your expected frequency? You're going to go back to your matrix, second here. And then you're going to see we input the observed frequency on A here. We already have the B, so we're going to go to the B. And then go to edit, enter. So you can see they do have the expected frequency here, 45.96, 60.03, 234.18. Okay, you could get all of them. Okay. Okay, example 3. I want you guys try to do it by yourself. Find the subtotal, grand total, find the expected frequency, and then state the null and alternate hypothesis. Okay, check your work. Okay, double check your grand total here, 665, so match with the sample size here. And then find the expected frequency. Okay, I'll show you guys all the answer here. This is gonna be your expected frequency. One more time on the exam, I need you guys to show me the work. And then hypothesis. The null hypothesis will be marital status and educational level are independent. So the alternate hypothesis will be a not independent. State the condition. Samples are random and independent. And then expected count at least 5 for each cell. Okay, so double check here. At least 5 for each cell. Good. Okay, test statistic, you should get 39.97. Degree of freedom, how many row, how many column here? So we have 1, 2, 3, 4. 4 row, 3 column. Okay, 4 row, 3 column. So that will be equal to 6. P-values, you're going to get 0. So compare with your significance level, you're going to reject. And then let's say there is sufficient evidence to support the variables marital status and educational level are not independent. Okay, I show you guys one more time how to use your calculator. Okay, go to second, matrix, go to edit. Okay, this time we have 1, 2, 3, 4. So 4, enter, 3, enter. And then you're gonna input it, 15, 59, 10, 98, 240, 70. Okay, double check your work. Okay, right? And then quit. And then go to the stat, go to the test, go up, chi-square test. Go to calculate, enter. So check your work. Test statistic 39.97. Degree of freedom is going to be equal to 6. And then p-value 4.617 times 10 to the power of negative 7. So that will be equal to 0. Okay? And then let's go back to see the expected frequency. Matrix. Go to edit. Go to number 2, enter. So you're gonna find your expected frequency. Okay, 18.06, 87.735, 24.08. This is good, okay? For sure, that's a 1 questions on the midterm and also on your final, okay? That's it.